Good morning, students. In today's class we are going to see what are composite functions. So to understand composite functions, let us take a function defined from a to b and another function g which is defined from b to c. So the domain of the function is this set. This is the codomain of the function. Likewise, this is another set C. So the function f is defined from set A to set B, and the function g is defined from B to C. So here the composition of f and g, okay, f and g, this is denoted by this. You read it as GOF or you can read it as g of f. Okay, so the GOF function, this is the GOF function. So here we can write down that the GOF function is basically defined from A to C. Now here GOF is a well-defined function if range of the function f is a subset of so here the function GOF, this is basically called a composite function. Here we are defining composition of f and g, which is defined as GOF. Similarly, we can define here composition of g and f, and this is expressed as this. You read it as fog or f of g. Likewise here fog is a composite function and fog is well defined if range of g is a subset of codomain of f. So here when we are saying composite functions here, that means we are referring to GOF or fog, and these are well defined whenever this condition holds true. So now here, coming back to this part, there is a composite function GOF which is defined from set A to set C. Alright, now let us see an example of a composite function. Let us define a function fx as sin x from the set of real numbers to the set of real numbers. Let us define gx, suppose x square, which is again defined from say R to R. Alright, now here let us find out first of all whether GOF is well defined or not. So we know here what is the condition? Range of f. So the range of f, this is the range of the function f, which is the set of real numbers. This is subset of codomain of g. Here is the codomain of g, which is again set of real numbers. So condition is satisfied here. That means GOF is a well-defined function. If GOF is a well-defined function, let us find out what is g of fx. So g of fx can be written like this, g of fx, and here what is fx? Sin x function this way. This means that in the function g, the new variable is sin x. Our function g is x square. So now instead of x, our variable is sin x. So what are we getting here is sin square x. So this is the Goff function. You can call it a composite function. Similarly, if we find out here f of g, again check here that range of g is a subset of codomain of f. So this is a well-defined function and it can be written as f of gx, and gx function here is x square. This means that in the function f, the new variable is not x, it is x square. So the function f is sin x. Instead of x, we write down x square. So this is another composite function. So in general, the composite functions are not commutative. That means the Fogg function will not be equal to the Goff function. So now let's see how to identify composite functions. So we'll start here with the trigonometric functions. See, the standard trigonometric function is, say, sin x. I'm taking a sine ratio, it can be any ratio. If you make any changes in the angle, that means angle is 2x, or the angle is x cube, the angle is root x, that means any change in the angle will make this a composite function. Look at the sine function itself. Change the power of the sine function, sin x to the power 7, or you can write down square root of sin x, which means basically this, or this. So here instead of this I'll write down positive 7/2. So here look at these functions. You have changed the power of basically the sine function. This is also composite function. That means whenever for a trigonometric function the angle is other than x and the power of the function is other than 1, it can be sine square, it can be sine cube function. In that case, the function can be easily identified to be a composite function. We can have a combination. Power of sine is changed and the angle is also changed. Power of sine function is 7 and the angle is root x. Power of sine function is 9/2 and the angle is 2x plus 7. So these are all examples of composite functions. Now here I have explained composite functions using sine ratio. The same thing applies to the other 5 trigonometric ratios. So this is one shortcut method to identify composite functions. Let's think of a standard function, say x to the power n. Here, as n here is some real number, alright. The moment you change the base of this function, that means it becomes x square plus 2, power is any real number, so let us take 3. This is a composite function. Change the power, the base is this and the power is 3, so this is a composite function. Again you can change the base to x cube plus 4x upon plus 1 upon 5, and this is raised to power 4. This is a composite function. So you can see here our standard function is x to the power n. The moment you make changes in the base of the function, here is the base, this is the base. If the base of the function is other than x, then also it becomes a composite function. So you have to notice here that the power should not be 1. The power is any real number other than 1 or even 0. So now we have a basic idea of identifying composite functions. So when we say composite function, we are basically talking of composition of two functions, two real functions, composition of f and g or composition of g and f. So now in the next class we shall see how to differentiate these functions and then how to check continuity of composite functions.